Good afternoon, everyone. Welcome to our presentation. We're going to talk about securing and migrating older technologies to newer technologies, or old projects to newer technologies. We picked this topic because we've both been working on StudyLink within that company, and as you might also experience in your own work, it's not always feasible to go use the newest platforms, the newest features and frameworks and what have you in your old projects. So you have to migrate them. You can't rewrite them because of time and costs. So that's why we picked this topic, and we want to talk to you about some of our use cases that we had within our project. First of all, my name is Lars, and this is my colleague Georgia. As I told you, we both work on the same project, StudyLink, for quite some years now. We both work at Netcompany. I think you remember it from our keynote earlier this morning. We have a headquarters in Denmark. Delft is just acquired a few years ago, and we have been going through transitions because of this merger. And that's also quite some of the reasons we had to go to newer technologies within our project. Netcompany is like a lifetime company, so we're in all sorts of markets from the start to the end. And specifically for StudyLink, we're of course a bit in the education zone, so people going to higher educations or universities. Let's go to the agenda. I will first do a bit more introduction on StudyLink to give you some context on where we're coming from and what we have to work with. Then our use case about upgrading our .NET framework. Then we go from on-premise to the cloud, how we did our source control migration, and then Georgia will talk about CSP policies in our React framework, and securing and upgrading the NuGet packages for React. And if you have some questions, or yeah, you can save them till the end, or you can just raise your hand and interrupt us during the presentation. StudyLink, some of you might know, others might not. So just a small introduction is our national system for students to enroll for universities and higher education. We have therefore about 2 million users annually, which are students, but also employees from the universities, which are 56 institutions. They'll send about 5,000 messages an hour and also 10,000 emails, and those are like averages. We also experience a lot of peak moments throughout the year. We use technologies like Azure, .NET, SQL Server, React. Up till now, we have roughly spent 100,000 hours of development, and we have a 7-year contract for the hosting and maintenance of this application. We also have some external parties we have to connect to. We have ADOS, which is a European login tooling. We have a coupling with Duo, we have banks, we have IND, we have DigiD, we have student information systems from the different universities. So there's, just to give a context on how many stakeholders we have, and we are working on this project with a Scrum team of about 10 employees. We have 3 operational colleagues, and then some support desk who answer the student questions. So just a bit more numbers on what we face with this relatively small team with a large application and a lot of stakeholders. Lots of messages on the top, many users, many questions, quite some payments. And yeah, as I said, it's not only averages, but also the peak moments during the SMP, as you see, is the selectie and plaatsing, which is like the numerous fixes, educations on a university. You have to enroll by certain deadlines, and that makes for a lot of peak moments. Well, Georgia will now talk about the upgrade for our .NET Framework version.
From me, hi. So one of the biggest undertakings that we had while working on steadily was in 2018, when we wanted to upgrade from the .NET Framework version 4.6.1 to 4.8. At the same time, we also wanted to upgrade from Visual Studio 2015 to Visual Studio 2019, and also upgrade all of our NuGet packages. As you can expect, that presented some challenges, especially given the scope of the Studio application, which is comprised of around 50 .NET projects, 20 custom-made NuGet packages with interdependencies, and you can see the interdependencies in the graph on the right, just to give you the scope of the complexity. So we have around 70 repositories, which was at that point with TFVC, and that results in hundreds of builds and release pipelines. At the same time, the client also wanted, and we wanted to provide the client features and content, so that was an additional challenge that we had to face. Our strategy was to perform some initial trial runs. So for each type of application that we had, or every type of functionality that we offer in steadily, we tested this upgrade, and we also did that for one single NuGet package solution locally. Then we wanted to update all of our solutions. So we had to go from the root of the previously showed diagram to the nodes, to the child nodes, slowly upgrading our NuGet packages and the version of .NET Framework that we were using. We also have a lot of build scripts that are used during development and during release. Those also needed to be adjusted. And on the operations side, we had to upgrade and adjust our CI/CD pipelines, meaning that we had to install .NET 4.8 framework on our web servers, update the on-premise build agents so they would use the Visual Studio 2019, and update all of our build pipelines. And to cover the last challenge, half of the team was working on the release branch and trying to do this upgrade, and the other half was continuing with developing the features for our project. Some of our learning points, when you're trying to do this kind of big scale changes, it makes people nervous. So we had to appease the stakeholders, and they always wanted to get an update, which we did later on. Theoretically, it's easy to sell that all of these changes being done at once is something good and it's something doable, but it's harder to execute that than you would expect. Like you saw from our diagram, if we made a mistake and we forgot even one of our dependencies, then it would cost a lot of time. Lastly, mistakenly, we did not have a way back to go from the way we were working. So if something went wrong, we had to start from scratch, which was also a learning point for us. No, sorry. Went too fast there. So from our conclusions, you need to be able to appease and prepare mentally both the developers and all the stakeholders involved, so they know that things keep functioning as they should, and that things are progressing as expected, even with hiccups appearing. You need to find a way to measure this progress and easily show it to the stakeholders so that they know that things aren't as bad as they might seem at various points. At the same time, producing the functionality gives a sense of safety to the client, so that is also important. As I said, don't try to do everything at once. That was a mistake. Trying to do both the .NET Framework upgrade, the upgrade of the NuGet packages, and the move to Visual Studio 2019 in one go was not a good idea. We would not recommend it. And in general, you need to keep a positive spirit and bring some optimists along for the ride so they can keep a positive attitude. My colleague Lars will continue with the next topic.
Yeah, after the .NET Framework update, I wasn't actually working for a Netcompany at that time, so I just joined during this migration of TFS. I had the the luck to guide it and to get people along and gather some experience on these migrations. In the So the goal for this migration was to investigate the currently largely undocumented processes that were created during development. There were a lot of custom-built tasks. All the experience was gone from the team. The people who remained were, getting along, developing new features, but the CI/CD was working, and yeah, now we have to go to the cloud. Good luck. So that was one of our goals as well, modernizing the way of working. All the old stuff was on-premise, and it was for the old company, and that company wanted everything to the cloud, to the new domains. Yeah, challenges. So that was the next goal, was getting the development environments also in line with how production is working. We have a bit of a setup with forward-facing for students servers, and then back-end servers that are not accessible through the internet. And we didn't have that as developers. As developers, we just had a dev machine somewhere in the building, and yeah, just drop your stuff and go. We also want to improve and modernize our deploy and release process, because deploying and releasing involved a lot of custom tools, just because, well, we were only 6 developers at that time, and they had to manage 60 plus projects. So it took, I think, a week to do a regular release. That's not nice for the client. And for yourself as well, because it's a lot of hassle if you forget stuff. So yeah, the challenge is lifting the old TFS infrastructure to the cloud. It involved build agents that were also hosted locally. The virtual machines were locally. Databases were local. Source code, well, TFVC, also local. And the hosting of NuGet packages and NPM packages, well, you guessed it, also local. So yeah, just as a scope for the project, we could spare 2 developers to migrate this. And during that period, of course, also new features were constantly added to the project. Also, the people who initially created the project had TFS projects, but all different projects in the same organization, which made it hard to maintain, hard to track whatever was deployed, because every project for itself had its own CI and CD pipelines. It did have a nice separation of content, but for a small team it was too much overkill. Yeah, and then what I said, the challenge, we wanted minimal disruption for the client, so we had to build new features just to, to keep them happy and give them new stuff. So what was our strategy? Dry runs. Create a template, new organization, create a new project. You can do it for free in the cloud, and then just start by small projects. The strategy, as I have on the bottom right, is the old situation was TFS could deploy to the old VMs. And our strategy was, okay, let's build the new cloud VMs for the developers first, go from TFS to the new cloud, so we have the new environments up and running with source we know and we can control. And then the second developer was also doing step 3, which was looking at how can we migrate TFS to Azure DevOps. And we wanted to automate as much as possible, because 2 developers isn't much. 50 projects is a lot of work. So the more we automate, the faster we can go and tweak it and make it organized, so that in the future everything is, set up in the same way. yeah, so essentially prepare and investigate as much as possible and automate the stuff. Well, our learning points from this whole endeavor. Try to balance the quality and the hours. We were a bit tipping to the scale, like we want as much quality as possible because we do this for our fellow developers. We want to make it life as easy as possible. And yeah, doing that, you might spend a bit more hours, than the client wants. The mindset, migrations take a lot of time, of course, and preparations. But also don't make the scope too ambitious, because we were also thinking like, yeah, we're at TFVC, we want to move to Git at some point. Maybe we want to do more fancy stuff with Azure and Kubernetes and cloud in the future. Way too ambitious. First migrate, and then later, as we'll do the topic after this, the migration from Git or TFVC to Git. Yeah, and also if you do dry runs, document them. That's yeah, seems to go without saying, but we did forget it at some point. And then yeah, it's just you can't keep track on what you did. Sometimes you have a month where you can't work on it because the client wants something, or you have a production bug. If you document it, you can go faster. Well, the conclusion was the preparation actually paid off. The automation was well worth the investment. Because we went to TFVC, we couldn't really work with as much infrastructure as code as we wanted. We couldn't use YAML like we wanted. So yeah, we had to use the UI, and with the scripting and using the Azure DevOps integrated API and some fancy Selenium, we were actually automating as much as possible. Yeah, so we had 2 developers working on it. In the end, we didn't really have any downtime for the team, so that was, for the customer-wise, it was really nice. Of course, it took more preparation to do it that way, but yeah. And then, yeah, primarily focus on the migration and on improvement second, because we also still have a lot of custom build steps, and we have to keep them that way because it takes even more investigation and challenges to get those out of the way. Yeah, so that's actually, it was a nice project. Just took a lot of time. Then, as I told you, we also have the source control migration from TFVC to Git. We actually just implemented this, and it was more, as opposed to the previous migration from on-prem to the cloud, we took this more organic. So we didn't have a lot of preparation time, but our goals were to make the product to market even faster, because even though we migrated, we still had about 4 days for a current release, yeah, which was still too long for a developer team. Reduce the release complexity. Well, it goes without saying that increases our release process. We wanted to use the pipelines as a code, so YAML instead of the UI stuff. And we wanted faster responses on bugs, so implement CI/CD in a way that we could actually yeah, respond faster to our production bugs. And we're getting there. But we face a lot of challenges. Like what kind of repository strategies to use. According to the internet, it's not really recommended to go for a mono repository. So we didn't. But yeah, long story short. But there are kind of pros and cons against it. Using a mono repository, it's a bit more on the maintenance technical side, but having a distributed repository is more like a challenge within the team with the workflow processes, because there are now 50 repositories, and all our developers have to be informed on what the strategies are for checking in and stuff like that. And they never worked with Git. So yeah, getting this little Git experience in the team and having to do the new work process is quite a challenge, I would say. And then at the same time, also designing a new release strategy. On top of that, little preparation time. I think we had 2 weeks before we could finally, and then we had to implement it. Yeah, so our strategy was we didn't want any history from our TFVC project. We just put an archive on it, and just go from scratch with Git. So that way we could actually just create empty repositories, drop the code in there, and then developers could go on their way and check in again. That was actually pretty neat. In one day we were migrated to Git using the source control that we wanted. Of course, source control is nice, but you still have to hook it up to your CI/CD pipelines. Else it's just version control and not, it isn't releasing stuff. So for our strategy, we also use the recommended strategy, which is just trunk-based development and creating release branches at the end of our sprints. This is a very nice strategy. It helps us a lot. It reduces the release time to, I would say, 1 or 2 days maybe. The challenge is the work process. People actually, checking in on the release, doing pull requests to the release branch to update it at the end of the stories, stuff like that. So therefore the learning point is actually, you want to keep these work processes in mind while you migrate, but you don't want to set them in stone. Don't fully document them before they are used. Let people use it. I actually pitch my idea, I think, daily in the stand-up, of course, but then also some more in-depth sessions with my fellow developers just to keep them up to date and have them involved. And by doing that, I got rapid feedback, but I also kept them involved in the process because I want the team to own this process. I don't want to be the knowledge guy. I don't want to spend the rest of my life helping people with Git. I want to do new projects. Yeah, so having these update meetings with the team regularly helped me actually distribute the knowledge throughout the team in a nice way, a natural way, I would say. And I got also people to think about these work processes as we went along. So that was actually nice. So in the end, the little preparation time was okay. But yeah, by keeping the team updated and keeping them involved, I could also manage their expectations. Like, yeah, we will move to Git on the first day. We just won't be able to release stuff, and therefore we cannot test stuff. Yeah. I did try to identify the key decisions, like what sort of repository strategy to use, what kind of branching strategy to use, and I think getting those key decisions clear before you start the project, you can organically do the rest of the process, but just, yeah, as long as you, during the progress that you made, you'll notice yourself like, okay, I'm now at this point where I remember this key decision, I have to make it, and I have to get people's opinions on it before I make it. Yeah, also communicate the end goal of your project. Like, what is my end goal? Is it just moving to Git, or is it also improving the release cycle and stuff like that? That really helped to get that clear. And of course for yourself, like if you know where you want to go, it's easier to follow the process towards that goal. At least it works for me. Yeah, and in the end, the releases went from 4 days to about 2 days, and that was on the first try. And we strive to do it more during the sprint, and then the releases will go to maybe 4 hours, hopefully. Georgia will talk more about our CSP policies.
Again. One other challenge that we faced was introducing content security policy in our front-end code in React framework. This was a requirement kind of imposed to us by an external provider after an audit, although we also wanted to do it for security reasons, of course. For those who don't know, content security policy is a policy in front-end code in a web application that allows you to say which sources are allowed to insert scripts, styling, images, media sources to your web application. And it adds a layer of security to your web application. As I said, it was a requirement from an audit, so we had a hard deadline and we needed to meet it. The CSP policy is challenging in React in general because of the way React works. We are importing a lot of libraries with a lot of inner dependencies, which you cannot keep track of, which means that the CSP policy becomes harder and harder to implement. We also had limited knowledge at that point of CSP policy, but the biggest challenge we faced was a customized React Select library that we were using throughout the whole application, which had an inner dependency with the emotion library, which inserted dynamic styling, and we had to deal with that in the time frame that was given to us. So we tried. First, our strategy to add an exception in the CSP policy regarding this troublesome package. The way to do that moving through content security policy is using hashes. However, you have to add a hash for every single instance where you're using the component, and that's not viable with the numerous instances that we were using in our application, so that was not a go. The other option is to use a nonce value, which is less secure as an option anyway, but also a nonce value is inserted in the component when it is rendered, and we needed to have a new value every time the application was uploaded, which meant that in order to achieve these, we needed to do server-side rendering, which kind of defeats the purpose of React, and it is technically difficult to achieve. So we scrapped that idea. And we went for our second strategy. Okay, what about if we replaced our troublesome component with another one that doesn't have this dependency and actually allows us to keep our functionality? We researched and we only found one viable option, but unfortunately it would reuse the functionality of the component that we had in our front-end code, which meant that it would have an impact on our users, on our the institutions and our students that were used to using the application a certain way. So inferior component, not a go either. So we had to go for another strategy, and we landed on this one, which meant that we would grab the component, download the version of it, and slowly remove the dependency that was causing the trouble from both the use of the code and the package.json of the component and the library, and then slowly introduce class names and IDs everywhere that the library was used, so we could introduce the styling through our own system that was allowed from our CSP policy. This proved to be a success. We had a component that was visually and functionally the same for our users with no visual difference for them once we made the switch. And from that sprang the idea about securing and updating our NPM packages also in React. As you may be aware of, there are some commands in NPM that allow you to scan for vulnerabilities of your NPM packages and automatically fix some of them with the NPM audit and the NPM audit fix. We also have the npm outdated command that allows you to see which of your packages are outdated. As we mentioned before several times, Steadily is an old application, which means that the versions that we're using, unfortunately, are from when they were first developed. And we need to slowly upgrade. So we will be using this. It's an ongoing process still. So we have our challenges for this. as I mentioned, big application uses a lot of libraries. There are a lot of dependencies between the packages, which makes it extra hard for you to upgrade willy-nilly whatever you want. It's an old application, so some of the upgrades will break the way that our code works, and we will have to do a lot of refactoring. And on top of that, we have the CSP policy, which we have already introduced in our system, and will probably give us trouble like it did with the React select component. Finally, as we said in the previous points that we wanted to make, our client keeps wanting content, keeps wanting development, while we are making this change, which adds an additional challenge. So our strategy is to introduce the vulnerability scan in our pipelines once we go to continuous integration and continuous deployment, scan these vulnerabilities, do a dry run with the NPM audit fix, see which ones can be updated automatically without any break in our application. Then for the ones that cannot be fixed automatically, we get the list of the manual fixes that need to be applied, investigate about the dependency, the inner dependencies, the dependencies between the packages, and the possible impact on the CSP, and then consider what that impact means for your application and move forward slowly and steadily. So our learning points, both from the CSP policy that we applied and the updating of the NPM packages, is that if you are considering adding a security policy to your application, even though at the time might seem easy, it needs a lot of time and careful handling. It is not always easy to substitute one library with another. It takes time, and you need to handle it carefully and see what your options are. And depending on the situation, as I showed, there could be multiple options. You need to choose carefully which one best suits your needs. Attention to the package dependencies, as I said, that was one of the biggest struggles with the CSP policy. And assumptions are dangerous. We thought, okay, we will add the content security policy. It's going to be an easy task. We're going to meet our deadline without problem. But of course, there were problems, like they tend to be. And finally, slowly and steadily investigating and doing your changes is the best approach. And thank you. We'll take questions now.